In this video, we're going to show the Rover motor speed measurements and display using Java beans using the Pyroraptor USB I2C bridge. Acts as a master and controls and scans I2C devices. The speed measurement on each motor is controlled with a PIC16F1937 through I2C bus. We use a MUX to address each motor individually. This is the USB I2C. Here we show the PIC16F1937. These are I2C slaves that provide a PWM signal to control the motors. Here we have the PIC1937 breakout, which is an I2C slave and measures the speed of each motor individually through a MUX. Now, here's a live demonstration. We have the 4 speed meters. These are Java beans in our Pyroraptor Java interface. We're going to turn on all the motors, so all 4 motors will be operational. You can hear them. And notice that the Java beans measuring the speed. So we're measuring the speed by communicating with the 1937 I2C slave, measuring each motor individually, and you can see the 4 Java beans showing the speed. All 4 motors running at a high speed. Now, here what we're going to do is stop it. You can see that the Java bean records a small speed. We're going to move one set of wheels faster than the other. You can see that one side is moving faster than the other. The Java bean speed meters reflect that, and you can see it in the video. Okay, so here we'll go back to all 4 moving at a high rate. So both sides are moving at a high rate, and you see the Java bean motor speed indicators indicating the higher speed. Also, the scope shows the encoder. Now, we're going to stall a wheel to demonstrate that we're measuring each motor individually. So here you'll see the Java bean to the lower left showing a smaller speed when we stall it. Let's do it again. So you see the speed drop. So each motor is being individually measured. Okay, we'll do that again. And look at the speed. It drops only for one motor, which we're stalling. It goes back up when we stop doing what we just did, which we don't want to do too often. So here we're going to stop one set of motors and let the other one run. So you can see that this one's running real fast. These are the 2 motors on the right hand side, and the other one is stopped. And you can see the Java beans measuring the motor speed, reflecting that. We have a stop command, which is not 100% stop, but it slows it down to a crawl. There's a little offset we can put in. But you can see when it's moving real slow, the Java beans reflect that, measuring each motor individually on a periodic basis. Okay, full speed ahead. Also look at the encoder on the scope. So that's through the quad optical encoder on a particular motor. And full speed ahead, they're showing the high speed. These are the Java beans. This is illustrating that the Pyroraptor can scan the I2C bus, and you see the address 51 and 52 for the saber-tooth I2C PWM controls. And here we stop the motors. Okay, here we show the saber-tooth motor controller, which takes 2 PWM inputs, and you can go forward, reverse, tank, clockwise, counterclockwise. They're controlled by the PIC16F1937s, which are I2C slaves, where we can give it commands. It generates the PWM signal Very nice way to control motors, controllable through the Pyroraptor USB I2C bridge, also through a wireless connection. Here we show the terminals that bring the controls from the Sabertooth to the 4 Pololu motors, and we do encourage using these terminal blocks with spades. We're also showing the PIC16F1937 and the prototype board, which includes the MUX, which under I2C commands can address each motor individually and measure its speed using the PIC16F1937 through I2C control. That does it. Thank you.